All right, so we're going to be talking about hyperbolas today, or hyperbolas. So what a hyperbola is it's a set of points P in a plane such that the absolute value of the differences between the distances from P to two fixed points called the foci, F1 and F2 is constant. So up here, here's my two foci. I find the distance here. The difference is always going to be the same. Doesn't matter where I find that point, it's always going to be the same. So we have two hyperbolas we're going to be talking about. We're going to be talking about ones where, quote unquote, it opens left and right or up and down. So when we're dealing with that everything's going to be on one central axis. So we don't have like an ellipse where we have a major axis and a minor axis. Everything's going to be along that one. And the nice thing about it is it follows whichever coordinate is positive. So in our equation, whichever coordinate has a positive sign in front of it, it's going to follow that axis. So here we have a positive x. So this is our opening left and right. So we have quantity x minus h, quantity squared over a squared, minus quantity y minus k, quantity squared over b squared equals 1. Just like in an ellipse, hyperbolas are always equal to 1. So if they start out where they're not equal to 1, divide it out and see. So our center is going to be what values make these 0. So this is going to be h and k. All right. Our vertices. So since x here is the positive coordinate, doesn't have a negative sign here, positive sign. What I'm going to do is I'm going to take the square root of a squared, which is a, and I'm going to add or subtract that to h. Now for my foci, so this brings us back to basically kind of like Pythagorean theorem, a squared plus b squared equals c squared. So I have a squared, I have b squared, I'm going to add those together, that gives me c squared. I need c, which is just the square root of that. So it's going to be h plus or minus c comma k. Now, when it's opening vertically, obviously what we're going to do is we're going to take those values and add it to the y value. Now, be very careful when you're working with a positive y, because there's a lot of times students will automatically think left to right. Oh, this is my first part of my coordinate, but it's the y, so it's the second part. So be careful on that. So example 1, what we're looking at is coming up with our equation. So they give us a center. That's nice because that gives us h and k right away. It gives us our vertices and it gives us our foci. Okay? Now, from our center, what we're going to do is we're going to look which value has changed. Well, the value that's changed is my x. So I know that's going to be the positive. So here I would have x minus h. Well, h is 0. So it's just x squared minus y squared equals 1 so far. I'm going to find a squared. I'm going to find b squared. Okay? So now I can find a squared right away because the distance from my center to my vertice is a. Okay, so I'm going to go 0 to 4. 0 to 4 is 4. So that's a. So I'm going to square that. 4 squared is 16. Oh, not 16 squared, just 16. Okay, so remember that's, in this case, a equals 4. Now c equals 5 because I'm looking at the distance from my center to my focus. That's c. Okay, so c equals 5. So remember, c squared equals a squared plus b squared. So I'm going to go 5 squared equals 4 squared plus b squared. 25 equals 16 plus b squared. I'm going to subtract off my 16. I'm going to get 9 equals b squared. Now I don't really need to find b, I just need b squared. So there's my 9. So I have x squared over 16 minus y squared over 9 equals 1. Okay, so there's my equation. So I'm using my center and finding the distance from my center to my vertice. That's either a or that's either b, depending on what coordinate is changing. I'm going to find the distance from center to focus. That's c. Okay, and using that information to find the missing piece. Now, on the next example, it's asking us to find all the pieces. It's asking us to find the center, to find the vertices, to find the foci, and then to graph it. Okay? So I notice that this isn't equal to 1. I have different coefficients, so I know it's not a circle. Okay, so I'm going to divide everything by 63. Okay, so I have y squared over 7 minus x squared over 9 equals 1. Okay, so I notice my y-coordinate is positive. Okay, so that's important because that's going to tell me which coordinate is changing. Okay, so I'm going to look at my x-coordinate first so I don't mess up my center. What makes that 0? Well, it's 0. What makes this 0? 0. So my center is 0, 0. Okay. Now for my vertices. My vertices are going to be taking this value here and square rooting it. So the square root of 7 is the square root of 7. So this becomes 0, 0 plus or minus the square root of 7. Normally I wouldn't write that 0 in there. I would just write it as plus or minus the square root of 7. So there's my vertices. Alright? So now I need to find my foci. So my foci are going to be such that c squared equals a squared plus b squared. So that gives me 9 plus 7. So c squared equals 16, or c equals 4. So I'm going to add or subtract 4. So my foci here is going to be 0, 0 plus or minus 4. Once again, I probably wouldn't write that. I might separate it into 2 points, but in fact, I might do that just to make sure I can see that. 0, negative 4, 0, 4. Now to graph. Okay, so graphing hyperbolas, I have a unique way that I like to show. It's kind of like that similar idea of ellipses, but it seems to help, get everything in position. So the first thing I'm going to do is plot my center. So there's my center. Okay, so now I'm going to take my a squared and my b squared. I'm going to actually find the square roots. So the square root of 9 is 3, so that's nice because I'm going to go over 3, and I'm just going to put a line there because I'm actually not going to put dots. I'm going to put lines because I'm actually going to create a box instead of an ellipse. The square root of 7, it's a little over 2, so I'm not, I'm going to put a little line here above and below 2. And now what I'm going to do is I'm going to create a rectangular box using those as my ends and my sides. Okay, so my graph's a little off here because I'm hand drawing it. Now what I'm going to do is I'm going to draw in my diagonals of that box. So the nice thing is the diagonals should go through the center. My coordinate plane is a little off, so I'm going to make dashed lines. Okay. Nice thing is I've already plotted my vertices here and here. Now these diagonal lines are going to be kind of the boundaries of our graph. We're not going to actually touch this. Those are asymptotes. So what's going to happen is I get really close to them. I come down, I touch my vertice, and I go up. Okay. So it's kind of similar to graph an ellipse. We're going to find those coordinates on the sides, but now instead of kind of drawing in a circle, I'm going to actually draw in a box, a rectangle, and I'm going to put in the diagonals and use those to graph my hyperbola. Okay. So that's hyperbolas. That's kind of finding out all the pieces, the center, the vertices, the focus, and how to graph them.